Welcome to the Deep Dive. We take stacks of research and pull out the good stuff.
That's right.
Today we're talking trench safety, and specifically we're going to break down OSHA's guidelines for using aluminum hydraulic shoring in trenches.
Sounds good.
This deep dive is presented by Safety One Source, your partners in workplace safety knowledge.
Great.
You know those trenches that appear safe on the surface but can turn deadly in an instant?
Yeah.
Yeah, those are the ones.
Those are the ones you got to watch out for.
We're diving deep into how to prevent those kinds of tragedies.
Exactly. And, sometimes the regulations can feel a bit like trying to read hieroglyphics, but we're here to help you decipher all that and really understand how to keep workers safe when trenching.
Okay, so you've got a stack of papers in front of you with a bunch of dense OSHA regulations.
I do.
Let's start with OSHA 1926, Subpart P Appendix D.
Okay.
What's the deal with this appendix?
Well, Appendix D is all about aluminum hydraulic shoring systems for trenches up to 20 feet deep.
Gotcha.
Think of it as your guide to choosing the right equipment and setting it up correctly to prevent those walls from caving in.
So are these guidelines like a one-size-fits-all solution for every trench?
Not at all.
Okay.
You can't just pick any shoring system and hope for the best.
All right.
It all starts with understanding the type of soil you're dealing with.
Okay.
OSHA actually has a system for classifying soil into three main types: A, B, and C.
Gotcha.
Appendix A of Subpart P is a great resource for accurately classifying soil.
And I'm assuming each soil type has a different level of, let's call it structural integrity.
That's a great way to put it.
Okay.
Type A soil is the most stable, solid rock.
Okay.
Type B is in the middle.
Yeah.
And type C is the least stable. Think loose sand.
Right.
And you know what they say?
What's that?
The weaker the soil, the stronger your shoring system needs to be.
Okay, so soil type is the foundation of everything. Yeah. Literally.
Mm.
But once you know your soil type, how do you go about picking the right shoring system?
Right.
It can't just be a guessing game, right?
Right, and that's where those tables in Appendix D come in. We're talking about tables D1.1 through D1.4.
Okay.
These tables give you specific guidance on which shoring components to use based on the soil type, the depth of the trench, and even how wide it is.
So if I'm looking at, let's say, table D1.1,
Hi.
what kind of information am I actually getting?
All right.
What should I be focusing on?
Well, let's imagine you've got a trench in type A soil, and you're going with vertical shores, which are those upright supports that hold back the trench walls.
Yeah.
Table D1.1 tells you the maximum spacing you can have between those vertical shores, depending on the size of the shores and the hydraulic cylinders you're using to brace them.
So I find my trench depth, my desired spacing.
Yes.
And then the table tells me what size components I need.
That's right.
It's almost like a cheat sheet for trench shoring.
You could say that.
Right.
But remember, even with these tables, there's a lot more to consider.
Right.
For example, the calculations used in these tables assume what's called simple span conditions.
Simple span conditions. That sounds like something out of an engineering textbook.
Yeah, it is.
Break that down for me.
Okay.
What's that even mean in practical terms?
Think of it like this.
All right.
Imagine a plank of wood resting on two bricks.
Okay, I got that.
That's a simple span.
Okay.
But in a real-world trench, things are rarely that straightforward.
Right.
You might have additional supports, uneven ground, or other factors that make the calculations much more complex.
So Appendix D helps you get started, but you always need to consider those real-world variables that could affect your shoring system.
Absolutely. It's never a plug-and-play situation.
Gotcha.
And to make things even more interesting, there are footnotes in Appendix D that provide additional information and limitations.
Okay.
You might be tempted to skip over them, but they can be critical for understanding the nuances of these guidelines.
I've got to admit, I'm usually guilty of ignoring those tiny footnotes.
Yeah.
But it sounds like they could make a big difference in trench safety.
Oh, absolutely.
Can you give me an example of a footnote that might surprise people?
Sure. Footnote B2 is a good one.
Okay.
It specifies that in certain situations, those 2-inch diameter cylinders you're using need to have structural steel tube oversleeves.
Oversleeves? Is that like giving the cylinders a little extra muscle?
Exactly.
Okay.
It's all about adding an extra layer of protection. And ensuring those cylinders can handle the pressure.
Okay, so these footnotes are full of hidden gems that could save lives.
Yes, they are.
What are some situations where the guidelines in Appendix D might not be enough?
Okay.
When do you know you need to go beyond the tables?
Well, there are a few red flags to watch out for. For example, if you have a giant excavator parked right next to your trench, that extra weight could put excessive vertical loads on your cross braces. In those cases, the members specified in Appendix D might not be strong enough.
So even if the tables give you the green light, you need to consider those external factors that could be adding stress to the shoring system.
Oh, got it.
And the same goes for situations where only part of the trench is shored.
That's right.
Okay.
Appendix D focuses on fully shored trenches.
Okay.
If you have an unshored section, things can get complicated quickly.
So Appendix D is a great starting point.
It is.
But it's not the be-all and end-all of trench safety.
Exactly.
Okay, I'm starting to see the bigger picture here.
Good.
This is way more complex than just slapping up some shoring and calling it a day.
It definitely is.
And to really understand how to apply these guidelines effectively, let's delve into some of the real-world examples provided in Appendix D.
Sounds good.
Let's do it. I'm all about seeing how this stuff actually works in practice.
All right. Welcome back to the deep dive.
Okay, before the break, we were talking about those real-world examples in Appendix D.
Right.
I feel like those are really key for connecting the dots between the theory and what actually happens out in the field.
They're so helpful for understanding how all of this technical stuff plays out on an actual job site.
Right.
And they highlight certain situations that might not jump out at you just from looking at the tables.
Okay, so walk me through one of those examples. What's a situation that stands out?
Well, Example 3 really highlights the value of those footnotes we were talking about. It describes a trench in type B soil where they're seeing a bit of, as they call it, rattling of the trench face.
Does that mean the soil is actually making a noise?
Not quite. It's more like a vibration or movement of the soil.
Gotcha.
It's a sign that things are unstable and there's a risk of a collapse.
Okay, yeah, that definitely sounds like something you don't want to ignore.
Exactly.
Yeah.
And this is where the footnotes come in.
Okay.
In this example, they point out that using those 2-inch diameter cylinders with the special oversleeves we mentioned can help address this issue.
Right, those extra layers of reinforcement?
Yes.
Those oversleeves are specified in footnote B2.
Yes.
If I remember correctly.
You've got a great memory.
When I try.
And just to refresh, footnote B2 specifies that these oversleeves need to be made from structural steel tubing with very specific dimensions.
So it's like adding an extra layer of armor to those cylinders.
Precisely.
Okay.
And in this example, they also talk about using plywood behind the shores.
Right.
Remember we talked about plywood earlier?
Yes.
To further stabilize that trench face?
Yes. It's all about having multiple layers of protection.
Absolutely.
So far, we've focused on vertical shores.
Right.
But what about those horizontal whaler systems you mentioned earlier?
Yeah.
Do the examples cover those as well?
Yes. Example 4 is all about horizontal whalers.
Okay.
It describes a trench in type B soil that actually has some characteristics of type C.
Okay.
So it needs sheeting to hold the soil back, and they want a system that gives workers 8 feet of space between the supports, those cylinders, so they have enough room to work.
Makes sense.
Right. So using table D 1.3, the example shows how to select horizontal whales, which are those horizontal beams with a specific section modulus. Plus it shows the right size for the 3-inch diameter cylinders and the timber sheeting they'll need.
Wait, section modulus.
Yeah.
Now that's a term that takes me back to my engineering days, which honestly feels like a lifetime ago.
It's a bit of a technical term.
Yeah.
In simple terms, the section modulus is a measure of how strong a beam is, how well it can resist bending under pressure.
So the higher the section modulus, the stronger the beam, and the less likely it is to buckle under the weight of the soil.
Exactly. In this example, they need a section modulus of 14.0.
Gotcha.
For those horizontal whales to handle the pressure.
Okay. So they're really serious about making sure those supports can hold up under pressure.
They have to be.
Right.
There's no room for compromise when it comes to worker safety.
You mentioned earlier that Appendix D doesn't cover every possible trenching scenario.
Right.
What are some signs that you need to think outside the box and go beyond those standard guidelines?
Well, one obvious one is trench depth. Those tables in Appendix D are only good up to 20 feet.
Gotcha.
Any deeper than that. And you'll need to consult section 1926.652 of the OSHA standard. That section provides alternative design methods and protective systems for those deeper trenches.
So if you hit that 20-foot mark, it's time to bring in the experts.
Exactly.
Okay.
Another red flag is layered soil.
Oh, right.
Remember how we talked about soil classification?
Yes.
If you've got a trench with different soil types stacked on top of each other, Appendix D might not be enough.
So it's not enough to just know the weakest soil type.
Right.
You need to understand how those different layers interact.
That's right.
And potentially impact the stability of the entire trench.
Got it.
And things like vibrations from traffic, nearby construction, or even just heavy equipment operating near the trench can also change the game.
That's right.
So even if everything looks good on paper, those external factors could create unexpected risks.
Absolutely.
Wow, this is way more involved than I ever realized.
It is.
You really need to be on top of your game when it comes to trench shoring.
It definitely requires a proactive and informed approach.
Okay.
Speaking of being informed, there are a couple other things in Appendix D that often get overlooked. Okay. But are crucial for getting it right.
All right, let's dive into those.
Okay.
I'm all ears.
First off, remember those hydraulic cylinders that are doing all the heavy lifting?
Yes.
Well, Appendix D is very specific about the type of cylinder you can use.
Okay.
Okay.
So I can't just grab any hydraulic cylinder off the shelf and expect it to work?
Unfortunately not.
Okay.
It needs to meet the exact specifications laid out in Appendix D.
Gotcha.
For example, if you're using a 2-inch cylinder, it has to have a minimum inside diameter of 2 inches and a safe working capacity of at least 18,000 pounds.
So using the wrong cylinder could literally undermine the entire shoring system.
Exactly.
And the same goes for those vertical shores and horizontal wales.
Yes, it does.
Okay.
Appendix D spells out the minimum strength requirements for these components.
It's all about making sure those components can handle the specific loads and pressures they'll be subjected to. And that's why it's so important to not only understand the tables, but to also really dig into those footnotes and the general notes.
Right.
They're packed with details and limitations that can make all the difference between a safe shoring system and a potential disaster.
That's a great way to put it.
It's like those footnotes are the secret code to unlocking the full power of Appendix D.
That's right.
Okay. I'm starting to feel like I could actually pass a quiz on Appendix D at this point.
Good.
Before we get too comfortable, let's zoom out a little.
Okay.
Appendix D is obviously focused on aluminum hydraulic shoring.
Yes.
But what about the bigger picture of trench safety?
That's a great point.
Yeah.
Remember, Appendix D is just one piece of the puzzle when it comes to trench safety.
It's like having a detailed blueprint for building a house.
Yeah.
But you still need to know all the building codes and regulations to ensure the entire structure is safe and sound.
Exactly.
So OSHA has an entire subpart P of 1926 dedicated to excavations and trenching.
That's right.
It covers everything from soil classification and selecting the right protective system to things like atmospheric testing.
Yes.
Because you need to make sure there aren't any hazardous gases in the trench.
That's right.
And even emergency rescue plans.
That's a good point.
So Appendix D is like the specialized instruction manual for aluminum hydraulic shoring.
Yes.
But you need to consult the entire OSHA subpart for comprehensive guidance on trench safety.
Absolutely.
And keep in mind that OSHA standards are constantly evolving.
Right.
What's considered best practice today might be outdated tomorrow.
Yes, very good point.
That's a great point.
Yeah.
So where can our listeners go to find the most up-to-date version of Subpart P and stay informed about any changes?
The OSHA website, osha.gov, is the ultimate resource. They have everything you need.
Perfect.
From the full text of the standards to interpretations and even compliance assistance resources.
Perfect. So today, we've really gone deep into the nitty-gritty of Appendix D and explored those critical OSHA regulations that govern trench safety.
It's been quite a journey.
It really has.
Yeah.
Now, before we wrap up, I have to ask,
with
all the advancements in technology, do you see any emerging trends or innovations that could change the landscape of trench shoring in the future?
That's a great question and one that I think about a lot.
Yeah.
There's definitely a lot of potential for innovation in this field. For example, we're seeing increasing use of sensors and monitoring systems that can provide real-time data on soil conditions and how the shoring system is performing.
So it's like having a smart shoring system that can alert you to potential problems before they turn into a major catastrophe.
Exactly.
That kind of proactive approach to safety
is
going to be key in preventing trenching accidents.
Absolutely.
And we're also seeing some really cool advancements in materials, science, and engineering.
Oh, yeah.
They're developing lighter, stronger, and more adaptable shoring systems all the time.
That's right.
That's really exciting.
Yeah.
It seems like the future of trench shoring is going to be a lot safer and more efficient.
I believe so.
That's great.
And as technology keeps advancing, I can't wait to see
what
other innovative solutions emerge.
This has been an incredibly informative deep dive.
It has.
I feel like I'm walking away with a much deeper understanding of the complexities of trench shoring and the crucial role those OSHA regulations play in protecting workers.
And that's what it's all about.
Yeah.
Ensuring everyone goes home safe at the end of the day.
Well, it looks like we've reached the bottom of this trench of knowledge.
We have.
But before we climb back out, any final nuggets of wisdom you want to leave our listeners with when it comes to aluminum hydraulic shoring and trench safety in general?
I think the biggest takeaway is that trench safety is not something to take lightly. It's not as simple as it might seem on the surface.
Right.
You need to really understand the regulations, plan meticulously, and be committed to using the right equipment and procedures.
Right.
Appendix D is an invaluable resource, but as we've discussed, it's only one piece of the puzzle.
It's like having all the ingredients for a gourmet meal.
Right.
But you still need to know the recipe and have the skills.
That's a great analogy.
To put it all together.
And remember, conditions in a trench can change quickly.
Oh, yeah, for sure.
What might be safe one minute could become hazardous the next.
Right.
So ongoing monitoring and vigilance are absolutely essential.
It's not just set it and forget it.
No.
You need to keep your eyes peeled and be ready to adapt.
Exactly.
And never hesitate to reach out to experienced engineers or safety professionals.
Right.
If you encounter a tricky situation or have any doubts.
Good advice.
When it comes to trench safety, it's always better to err on the side of caution.
Absolutely.
Couldn't agree more. A huge thank you to Safety One Source for sponsoring this deep dive.
Thanks to them.
And for always championing workplace safety knowledge.
Absolutely.
And to our listeners, we hope you found this deep dive not just informative, but empowering.
Yeah.
We encourage you to keep digging deeper.
Keep learning.
Explore the full OSHA standard and all of its resources.
Yeah.
Remember, knowledge is the most powerful tool we have when it comes to preventing accidents.
That's right.
And keeping workers safe.
It is.
And on that note, it's time for us to climb out of this trench and get back to the studio.
That's good.
Until next time, stay safe out there.